This is lesson 5.3, solving quadratic equations by finding square roots. So up to this point, we've had things like radicals that we just simplified. So I would say, okay, if this is a square root, I'm looking for numbers that are squares under here. So I would change the square root of 20 to be 4 times 5. And then I would know that the square root of 4 is 2. So this would be simplified to 2 square root 5. So this was just simplifying, kind of like if I had the number 3 plus 4, I could say simplified that as 7. But what we're going to do today is solving. So it would be like having an unknown plus a number equals a number. This is solving because we're actually finding the solution that works for x. So this would be a linear equation to solve, and what we're going to do today is solve quadratics. And in the last couple of sections, you've noticed that a quadratic is a number that has an x to the second power. So let's just start with something like this. So I'm still going to have a quadratic, so x squared equals 36. So what I'm wanting to do is find the value that works for x. What could I put inside here, square the number, and get 36 for the answer? So some of you may already be thinking, well, that is x equals 6, because 6 squared equals 36. But others of you might think, well, 6 isn't the only number. I can also have negative 6 for x, because when you square negative 6, you get a positive 36. So notice on this problem, I'm actually going to have two answers. And the reason I'm going to have two answers is because this is x squared. Up here, when it was a linear equation, I had one answer. It was x to the first power. Here, I'm going to have two answers. So let me show you the process for solving this one. So when they're not so easy to tell what the number is, we have a method. So anytime you have a squared problem, you can undo the square. Just like on this problem, because this says addition, if I wanted to solve it, I would undo by doing the inverse operation of subtracting, because the inverse of adding is subtracting. So I have to think about what the inverse operation of squaring is. And to undo a square, you take a square root. So over here, the square and the square root undo each other, and I get x. And over here, I get 6. But to show that I get both answers, anytime that I square root both sides of an equal sign, my answer is always going to be plus or minus. Let's do another problem. X squared plus 3 equals 24. So I want to know what number could I put in for x that would make this a true statement. So I'm going to basically undo the equation. So I'm going to start by getting rid of the 3. So I get x squared equals 21. And then I want to get x by itself, so I'm going to square root this side, and I'm going to square root this side. And when I square root this side, I know that I'm going to have the plus or minus version. So the square and the square root undo each other, so I get x equals, and I don't know what the square root of 21 is, and it doesn't simplify, so I'm going to leave it as plus or minus square root 21. Here's another one like that. 2x squared minus 1 equals 31. If you want, you could pause the video and try this one on your own. Okay, hopefully you've tried it yourself. So let's start. We're going to undo this problem. If I was working the problem, I would square it times by 2, subtract 1, and get the answer. So I have to go in reverse order. So the first thing I'm going to do is add 1 to both sides. So I get 2x squared equals 32. Then to get x by itself, I'm going to divide both sides by 2. So I get x squared equals 16. And now, to undo the square, I'm going to square root both sides. So I get x equals, and remember when we square root both sides, we get plus or minus. And then the square root of 16 is 4. So this means that I could go back up here and put 4. 4 squared is 16. 16 times 2 is 32. 32 minus 1 is 31. 4 works. Also, if I put negative 4 in here, it would work too. These are the only two numbers that make this statement a true statement.